So this is meant to be a Zoom call, but turns out for the last session we ran, we lost the first half of the session. So what I'm going to do is, luckily, because of me stuffing around, in the first half of last week's session, we only worked through bindOptional. So I'm just going to quickly go through bindOptional, and then we can just jump straight into the second half of the sesh last week. So we were kind of last week we got to this point where we're on mapOptional, and we implemented that, and if we kind of jump into the REPL, we can see that we said, all right, cool, if I mapOptional, if I map +1 over our full of 5, we expect full of 6. So mapOptional is great. We love this idea of taking some function and mapping it to the this inner context, and you can look at full of 5 as some type that contains a value or produces a value, and we saw that you don't have to just even though we've got full of 5 where 5 is integer, we don't have to stay in the world of integers. We could just as well say, all right, I'm going to map this function, this lambda. I'm not going to worry about the argument. So this underscore just says, hey, if I put n there, n would be 5, but I'm saying I don't care. I don't care what it is, and I just want to return hey. And now when I map this over, we get a full of hey. So you can almost think of the mapping, right, as it goes and replaces what's inside with what you return from the function, right? But it's always within this context of the type, right? Or the optional type in this case. So we've got this, and that's good. But what if we don't want to return a full of 5, right? What if we said, okay, that's great that you can give me the value inside, and I can call a function on it, and I can change the value inside, but I just want to change the whole thing, right? I want to say something like, give me n, and I'm just going to give you empty, right? So I just want to return empty. I don't want there to be a full of something. I just want this to just like here, mapOptional evaluated to a full of hey. I just want to evaluate to empty. Or maybe a better example would be to say if n is greater than 5, then we're going to return empty, or rather full of n, or n times 2, else empty. So we're going to say, so this lambda just says, give me the number inside the full, right? If that number is greater than 5, then I'm going to give you a new full that contains the number times 2. Otherwise, I'm going to give you empty. So if we said full of 10, right, we'd expect to see full of 20. So where were we? So we were kind of here, and we're getting this, this weird kind of, non-type variable argument in constraint. And basically, all we had to do is just had to make it a bit more. Haskell got a little bit confused here because it said, well, I'm not sure exactly what you want to do here, right? You're going n times 2, passing it to 4. So we have to just make it very clear that we want to times, where am I? We want to times n by 2, then pass that to 4. Okay, cool. So what we're trying to say is that, there are times where we might want to do something completely different. Like we don't want to just, right now, if we kind of thought, okay, cool, we're here, mapOptional, we said if n is greater than 5, then return a full of n times 2, else empty, right? So if we did this, at first you think, oh, well, if it's for full of 10, we expect full of 20. But we get a full of 20, right? And just like if we said full of 4, well, that's less than 5, so we expect an empty, we get a full of empty. So this using map here doesn't quite get us what we want, because what we really wanted to say is, in the case where we pass full of 10, we wanted to return full of 20. But in the case of full of 4, we wanted to return empty. And map optional, right? So the map operation just says you don't get to dictate what the return value is. You only get to run on the inside, on this kind of context. And so if you give me a full, right? If you give map optional a full, it's going to give you back a full every time. Doesn't matter what you return, you'll get a full. You might get in this case, you got a full of empty, but you'll get a full. Likewise, if you pass it empty, you always will get empty. And that's not, in that case, we didn't get empty from here, right? I could say full of n times 3, and I get empty, right? So in the case of map optional, you give me an empty, I give you back an empty. So we want a function such that we want to be able to do the same thing, but we want to be able to actually change the value being returned completely, just not a piece of that return value. Right? And we can kind of see that in the case of, say, full of 10, we just saw 10 was just replaced with full of n times 2. And that's what map does. Map just goes like, bang, runs it in the context and then gets out of there. But we're kind of constrained here. We want to be able to take a value, and in this case, make some choice and then return a different value of that same type. Now notice that I can't. Oh, okay, we'll get to that. We'll get to that when we get to bind. So that's really what bind optional is. Bind optional lets us do exactly this, where we can say, I'll take some function and then I'll return you a whole new value, not just the value to be replaced within the context. I'll give you a brand new value. So in a case of optional, it says, I'll give you a new optional, as opposed to kind of like it will say, I'll give you so you can give me a full and I can give you back an empty. Or you give me an empty, I give you back a full. That's, map can't do that. Map has to give you back the same value, just with a different value, same optional value. What the optional holds could change. The value of the type of the optional, the type of the value inside the optional can change, but give you a full, give you back a full. Whereas bind lets you say, hey, give you a full, give back an empty. I give you an empty, give you back a full. So that's what we want to implement, this bind. And it says, try and run it, and it says, what are you doing? You haven't even started with me yet. So let's kind of jump in and have a look. So we get some information that says bind the given function on a possible value. So we see in the case here, if we bind optional full and empty, now that's a little bit weird, right? How can you pass full to empty? Now, if we look back, what's the type of full? We know full is just a value constructor. And so it has the type, you give me some A, right? Give me some value of type A, and I'll return you an optional of A, right? So in this case, this is no different to us just saying, actually, what would happen if you said map optional full? So all it does is it says, okay, give me the value. And so in this case, we saw the type of full, right? It says, give me an A, give you an optional A. So in this case, 10 would be the A, right? And we get back an optional of A. So in this case, an optional of 10. Well, no, that's kind of not really the way to think about it. Another way to, So if we were here and we said, oh, okay, what would it mean to be to call, full with bind optional? Well, we can think of it like, what would it mean to call full on map? So you look at the type of full. We know full is just a value constructor, right? So it says, give me some value of type A, and I'll return you back an optional of A, right? So if you give me something of type in, I'll give you back an optional of in. So let's do that. So if we said map optional, full over full of 5, we would expect that 5 would be passed to full, and full would just return us something of optional in, right? And so it does that, right? It replaces 5 with full of 5. So it's, it does the exact same, it kind of behaves exactly how we expect, right? That, full is a function, given a value gives you something of type optional, or optional A. So that's fine. We can do that. So bindOptional, right, says, well, in this case, you give me this value constructor full, right? You give me the value empty, and it gives me empty, right? So in this case, because it was empty, just like in that optional, we don't call a function. With bindOptional, it's the same thing. If the value is empty, we won't call, right? Just like for map, we said, all right, map optional, n times 1,000, thousand, and you give me empty. It just says, well, I'm not going to call your function. I've got no value to call your function on. So bindOptional does the exact same thing. It just kind of short circuits. It says, oh, I know you gave me a function to call, but I'm not going to call it. I'm just going to return back empty. And this is a bit like our example, right? So in this case, it says, all right, if n is even, then return me a full of n minus 1 or a full of n plus 1. So if you give me a full of 8, 8's even. So it goes, I'll give you a full of n minus 1. So let's jump in. So we've got this bindOptional function, and we look at its type, and it says, I take a function, given in something of type A, returns an optional of type B. And then I get an optional of A, and I return optional of B. So whenever we're implementing a function, we've got to think okay, what's the arguments in? What's return value out? And so we know we've got, you can think of this like we've got two arguments, a function and an optional of A, and we're going to return optional of B. So we can kind of just, without even thinking, we can just jot that down. Okay, cool. Got a handle on the arguments. Well, so now we've got this optional A, right? So we know that this OA here is has type optional A. And so we've got to start thinking about, well, we've got to handle the different cases. And we know we have this case here where it says, if that optional you pass me is empty, has a value empty, then I don't do anything. So one kind of thing you might think of is all right, I'm going to pattern match. If the optional you pass me, if optional A is empty, I'm just going to return empty. And so we've kind of handled that case. That's good. And we can even you can even check that to see if that works. So you could say, okay. So you could say, take this case here, bindOptional full empty. So we could say bindOptional full empty. And great, does the right thing. Now, I could have had n, and I could return something of full of n times some big number. Still return empty. So that's looking good. So we've covered the case where the optional you pass me is empty. But we know that looking at the type for optional, it says it's a sum type. So it's either empty or it's full of some A. So we've got to handle this full of A case, right? And so we know, so we're going to destructure the other alternative, right? And we're going to say, well, if this optional was constructed with the full constructor, then it must have been constructed with full of some value, right? In this case, so now we know that x is of type A. So we know x is of type A, and we need something of type optional B. And so if we kind of just throw a hole in here, and we reload that, Haskell says, hey, I found this hole called underscore to do, and it has to be type optional B, which makes sense, right? Whatever you put for this expression here has to be of type optional B. You can't get out of that. That's the contract you signed. So you got to honor it. So it says, here are the relevant bindings that, like, here's the things that are in scope. Here's what you've got to play with. And it says, I can see an X, right, which is this X here, and it's of type A. Okay. And I can see an F, which is of type A to optional B. So you think, okay, I've got this X, which is of type A, and I've got this F, which is type A to optional B, and I have to return something of type optional B. What if I passed F, X? What if I applied F to X? Right? If I apply F to X, then it'll give me something of optional B, and voila, when it compiles, now if I give you something 4 or 5, it works. So it's really, it's kind of, in this case we just followed the types. We just said, well, we can get optional B using this function. Now, if you think about it, so if we kind of go back to our map optional example, that would have been a good one. Map optional. Okay, here we have this thing where it said if n is greater than 5, return full of n minus 2. And we have this kind of nesting, right? Because you can't get into that. You can't replace kind of the outer context. But now, if we replace this with bindOptional, it does exactly what we wanted, right? It kind of gets rid of this this nesting and says, no, just return me the next value. Just return me, instead of just replacing this, inner value, I can replace the whole value, right? So that's kind of the power here of bindOptional. It kind of lets you, at some arbitrary point say, hey, I'm going to take the value inside and return a whole new value depending on, what's contained within the optional. And what's really interesting is if you take the type of map optional and bindOptional, they look very, very similar, right? Like almost the same. The only difference is that for bindOptional, the return type for the function is optional B as opposed to B. And that tells you, right, that very subtle difference means a lot. It's a difference between this function, all it can do is run within the context of the optional, right? All it can do is run on the values the optional holds, in the case of full, as opposed to like it can go out and get me a brand new optional and I'll return that instead. So, this very subtle difference, but very different behavior. And that's kind of, a big theme here in Haskell is that you have these types that are just very different, very, very little, like not very, very different, like have very little difference, yet can give you a whole different behavior. And bindOptional as well here is that bindOptional, it's part of a bigger story in functional programming, like this kind of concept of binding, of taking a value and returning a new value, and then taking a value and returning a new value, is kind of a mechanism to a very big idea in FP. And so like we'll definitely circle back to bindOptional, because you'll see that we actually need bindOptional to implement a very popular technique in FP down the track, probably in after this. I think we start getting into that territory. So I'll stop here, but we're just gonna now just jump straight into the rest of working through this module on the call. Alrighty, I'm out.
You're on us now.
I am on. Where am I? Yeah, so this is kind of this is the power here of the.
Hang on, 10 minutes. So it's quarter to 2 now. So at 5 to
2, we're off.
Okay.
It's all over. Sweet. So that's kind of like, look, this whole bindOptional thing actually speaks to a much broader idea in functional programming, and it's kind of weird that it's like the second thing you do in the optional like type. but we'll kind of revisit this thing because this is kind of like a real key thing when it comes to like composing functions that do actual work. So if you jump back, not to there. Optional. So done bind. Now it's back to a little bit easier territory. So we're going to implement this function called question mark, and it says return the possible value if it exists. Otherwise, what does that say? The second argument. So for example, if I give you a full of 8 or like double 9, you give me 8, but I give you empty, you give me the default.
And what's the double?
It's just we defined it. Like we're just.
Oh right.
So we're going to implement this function that has this semantic. So what do we got? We got the type says we get an optional A and some A, and we return an A. So we get some optional A, we get something of type A, and we have to return something of A. All right, so it's an optional. So we got an optional. Most of the time, you just got to do pattern matching on the first thing because we need to pull this A out. And if you need to pull the A out, you usually just pattern match. So we'll pattern match on that, and we'll say if it's empty, we'll do something. Or if it's a full of X, we'll do something, and we'll call this like the default. Oh, that's not that. Default. So the default value will be of type A, and X will also be of type A. So, okay, empty case, what are we doing?
Wait up. Is this a function to just return its value of
it's kind of like an OR operator, I guess.
But I don't understand why you would, you're returning itself, right?
Well, you're kind of returning the value inside as opposed to the optional. So here we kind of lose the optional, and we're talking about A's at the end.
Yeah, so empty just returns. Wait up. So empty returns. We're passing in.
So this we have like in
a function and a parameter, are we?
Well, yeah, this is a bit funky with this. So this is really actually we just pass in something that's an optional of A. So the two arguments are an optional A and then just some A value, which has to be the same type as what's in the optional. So like in the case of here, the first argument would be full of 8 and the second argument would be 99.
Okay.
So if it's empty, if it's empty, we can't do anything with the optional A. We can't use that value, so we have to return the default value.
I'm just confused because we've got 3 of the same, we're passing in, we've got A.
Yeah.
So the optional A is
just return itself, right?
It's like a promise, right? It's like optional, it's like promise A returns A. It's like is that it's not exactly the same semantic, but the idea is there's fetch URL. You give me back a response, but I actually want the JSON of the I actually want the response, not all the meta shit around.
Yeah, exactly.
It's the same idea.
It's kind of like pulling the.
Yeah.
I mean, yeah, exactly right. I mean, your promise is like a wrapper type, just like optional wraps a value, and here we're saying it would be nice if when we're working with optionals that sometimes if it's empty, we just want to return the default or actually return the thing inside the optional.
Yeah, so when I think about this and I think on the empty, so it'd be we're giving it empty and def, right? So empty, it would correspond to the full of 8 and the def corresponds to the 99. Is that the way that we should be looking at this when we look at, on lines, is line 63 looking at line 6? Is that how I'm mapping that? Empty to full of 8 and def to 99? Is that
exactly. Yeah, exactly. In that case, that's the left-hand side, the right-hand side.
In that case, or I can look at it on line 3 where it's like empty and 99. So empty and def. So to me, that looks like it should return def. But
Got it?
I don't know if that's right or not.
No, exactly. Well, because what happens is Haskell will say, all right, okay, cool. Let's try and pattern match. All right, what's the first argument? Oh, is it empty? Yeah, sweet, it is. Okay, we'll take this path. We'll use this equation. We'll use this like definition. And in this definition, we just say, okay, it's just the default value.
And then if it's the next one, which is full of X or def, well, we give a fuck about our optionals. We want to return our optionals, but we want to unbox it. So we need to I would say just return X, but I don't know if that's possible either.
That's it, yeah. Because this destructuring means we pull out X. We kind of got a handle now onto X, and we can use it as a value. And that's it. What's it saying there? What didn't it like? There?
I hope I like the answer.
Because we just ignore that. So Haskell will sometimes whinge at you and say, hey, if you ignore that, it's going to be easier to not be confused by what you're using in the function. So now,
So what's the underscore used for?
so that's just saying that where are we? Map.
Unused variable kind of thing? Is it like the same idea?
It just says I don't care. I don't care about that argument. Like match on it, but I don't care about it.
Okay.
So it's kind of like a wild card. Match everything on that thing.
Okay.
Also, it's not like an underscore if you have like 2 parameters in a function in JavaScript and you only want to deal with like the second parameter, and so you will do an underscore. It's not the same kind of concept.
Same kind of idea in terms of like you want to get to the third thing by saying underscore underscore, then I'll have a name for the third thing. Like you can do like an array destructuring, and you're like, first 2 things I don't care, but the third thing I do.
Yeah, exactly. Yeah.
Same idea. If you didn't do this, then like Haskell will be like, well, I can't pattern match on that because it takes 2 arguments, and you've only talked about 1 argument.
But functions always take 2 args in Haskell, right? Always.
Take 2 args.
Can you take 1 arg in Haskell? What is 1 arg? Like all the things we've been doing, it's like
you could have the identity function, which just takes 1 arg and returns it back.
Right. Okay. But could you do like a function that just takes optional A and returns A?
Yeah, you could just like pull you call like get value or something.
Okay, cool. Okay, sorry. Okay.
No, that's good. So now we can see that if we say empty or 5, we get back 5. But if we say full of 10, we get back 10. So that's, and we can use it in this like prefix notation by saying like full of 10 and 5 and wrapping up, and it's the same thing. They're like equivalent using an infix or prefix.
Cool and easy to understand. Love that fucking params question marks full of 10 in params 5.
You want to see it? You want to see a little bit of
it's
you know,
like
why not?
Obscure. Like it's like it generally doesn't want to be anyone's friend. You know, it's like once as little people are enjoying the language as possible.
Who wants to understand that? Like that's just do like wonder like if you go that, and we'll say it's a full of 15 or it's that. That's easy. That's so straightforward. What's hard about that?
It's like when you're trying to write like boobs in a calculator or something. It's like you're just trying to put some weird numbers in to get something else.
420 all day.
How do you have a good library of, you know, like all your kind of helper classes that we get in other languages that people will have a standard use for, or do you have to just code it?
No. So like this course is like us going back and implementing the standard lib.
Okay.
Like the whole like, you know, the optional type exists as it's called maybe, and like you have all the functions that you would need to do stuff with it. We're just like, this course just like kind of pretends as if that didn't exist, and you're gonna have to like from first principles go and build it.
Yeah.
All right, it's 5-2.
All right.
Thank you, Cam.
That was great, man.
Thanks. I think maybe next week we'll finish optional.
Cool.
Maybe if you're lucky.
It was good a full of finish.
What's it? I mean, yeah. Actually, no. Don't. I'll ask in the Slack. I won't take up any minutes stuff. Thanks, man. That was great.
All right. Well, have a good weekend.
You too.
Yeah,
man.
you too. Yeah, you too, Damo.
Hopefully, you guys don't dream too much about Haskell.
Yeah. Oh, it will be a nightmare.
It's a bit of a That's a
Not
nightmare.
a dream. That's right.
All right. Yeah.
Bye.
All right. See ya.